Here we're going to understand how to determine the ratio or a fraction if it's terminating or non-terminating recurring. So the main funda here is it is always about the denominator. Okay, so let me explain the procedure. You'll understand things better. Say you have a fraction. That fraction, you need to simplify it into a simplest form. So to make you guys understand what is the simplest form, it's nothing but if given a fraction, if you have the HCF to be non-one number, that is if it's not just one, that is if they are not co-prime number, you should reduce it. How? Here the case of 10 and 20, the HCF is 10, so I'll divide both the numerator and denominator with 10. So we have 1 by 2. Here in this case, both the numerator and denominator is divisible by 13. So this is 13 ones and this is 13 threes, 1 by 3. Here, both of them clearly is divisible by 17. 17 2 is 17 6. Even 2 by 6 is further divisible by 2, so it is 1 by 3. So this is how you reduce it into simplest form. Right? Once you reduce it into a simplest form, then check for the denominator. If it's in the form of 2 to the power of n into 5 to the power of n only. So here I put, it's an important sign, right? So you need to understand that what does only mean. Okay. So if it ends with only this set of numbers, then the fraction is terminating. If not, the fraction is non-terminating. First of all, let us express in prime factor form. I'll recall what is expressing in a prime factor form mean. So say all of these numbers are some part of your prime factor, right? Example, say 1 by 10, 3 by 14, right? Say this is 9 by 200, and this is 11 by 144, right? Something like that. All these are denominator values, and you need to reduce it into prime factor form. Example, here it is 2 to the power of 1 into 5 to the power of 1. Here it is 2 into 7, 1 and 1. This is 2 into 100, 2 into 50. Oh, wait. No, yeah, correct. 4 into 2 into 250, 2 into 25 and 5 square. So basically this is 2 to the power of 3 into 5 square, right? And this is 12 square. 12 can be written as 2 square into 3 whole square. So this is basically 2 to the power of 3 to the power of 2 into 2 to the power of 4. So now, which of this will terminate in terminating, and which of them will terminate as non-terminating recurring? Okay, this is non-terminating recurring. This is pakka terminating. As we can see, it is just made up of 2s and 5s. This is non-terminating because it's made up of 2, okay, but 7. This is non-terminating recurring. Okay. This is 2s and 5s purely, so this is terminating. This is anything other than 2 or 5, it is non-terminating. What if I get only 2s? Then also it's terminating. What if I get only 5s? Then also it's terminating. Okay. So I'll give an example. 4 divided by 25. 25 is 5 square, is it not? 0.16. You can go with something like 11 divided by 25 also. Whatever the numerator, that doesn't matter. 25 is 5 square, terminating, right? So anything that is only made up of 2s and 5s will result in terminating. Anything else, even though there are 2s and 5s, will result in non-terminating. Okay, so understand this part. The section is done. Everything else is quite simple. Reducing into simplest form, then expressing in prime factor form. All of this is basics. If you don't know about this, go back to math basics. You'll learn from there and come back to this section. Right. The main thing is this is your syllabus.